change screen, and I'm going to share my well, this is not what I want to share, but this is what I want to share. So what we did last time was, why is it now? You cannot see my browser, can you? I'm going to stop sharing and restart sharing. Sorry. And I'm also going, no, I started the recording. So let's see whether this time it works. Sorry. Now it works. Now it doesn't work. Now it works. So please open your notebooks so that we can have a back to the past to what we did. So first of all, what we did is we installed Hadoop on the CPU and the server that we are allocated, and we showed a first example just to make sure that the Hadoop engine was running correctly. We saw an example of grep, but without many details. The only thing that I showed you is that, well, it's running in a standalone, sorry, I'm sorry for this. Right. So it performs a grep function. You remember that grep is looking for textual patterns using regular expressions in textual documents. And it is very useful because this, when we only have the terminal, well, we can, with VI, for example, execute grep and explore the content of our documents, particularly of our code. Am I right, or I'm just dreaming? You are acquainted with grep, with the function, or not?
Yes, I think so.
Okay. Right. So we did that, and an important thing to, okay, so an important thing to see was that even if there is, we are running on a standalone version, the way the engine simulates the parallel execution is that it triggers the execution of several threads that will host the different mapper processes, and then it also have threads in order to execute the reducers and produce a result. And so what we discussed last time is that if you go through the log, you will see that jobs are submitted to the job tracker, and that the job tracker starts the mappers, and then at some point it synchronizes the results produced by the mappers. Since we have different processes, they are not completely synchronized. So once the set of mapper processes have terminated the execution, then it triggers the shuffling and sorting process, and then it triggers reducers in order to execute the reduce function. And what we saw is that at the very end, once, well, it controls this log, in fact, reports on all the interaction that the different, the mapper processes have with the job tracker. And of course, the mappers, even if it's a thread, they have this task tracker that is observing the execution, in order that the job tracker with the task trackers can interact and synchronize all the process. all this pipeline that starts with the execution of the map and the readjust function, and in between the sort and shuffling process. So this is all about this with all the log. And then at the very end of the, I had an error here. So at the very end of the I have to execute everything again. So at the very end of the session, what we saw is that the result is given on the file system. Okay, and if you well, you have to complete this exercise. So you have seen, of course, that when you see the result of the execution, what you see is the grep results, and then a log, a file called _success. Okay, if we are lucky and the result is success, well, there is nothing to be done, but then you see, success, that's the result. And then if we cut the file where it stores the result, we know that there are 20 occurrences of allowed. Remember that the pattern that we were looking for was allowed star, no? So we have 22 occurrences of allowed dot and 1 occurrence of the string allowed. And so, but if we do not cut the file where it produces the result, the only thing that we know is success. Okay, so it's very friendly, as you can see. Do you have questions until here? Did you manage to execute the second one and analyze? Particularly analyzing, anyone can execute this, but did you manage to analyze the second? Well, of course, the first one, but that one we did together. The second one.
Yes.
Okay. Can you comment on your observations? Do you want to share your screen and then comment on the different steps? What was the function, well, the operation that we implemented in this second example? Anyone? So you did execute, but you do not know what you executed.
Well, I think that well, we generated two files, a map function and a reduce function.
Well, you do not generate it. You used, well, you used two functions,
Well,
right?
yeah.
And what were we implementing through these two functions? What operation?
The map reduce.
No, MapReduce is the model. What operation?
The word
Map
count?
reduce, sorry, the word count, yes. Map reduce is as if we were saying object oriented or imperative programming, functional programming. Yes, that's true, but that's a way of programming. It's a philosophy of programming. And then we, using this model, we program things. Yes, it's counting words. And what is the general pseudocode or general description that was adopted in order to implement the map function? What do we have here? What is this first part?
Well, I think that what we do is basically, I think we're reading line by line in our loop, and then we are stripping, I think, leading and trailing spaces. Then we are, I think, by using the regular expression, I think we're just leaving words and like everything that's not, I think that's not alphanumeric. Well, alpha, no, like characters, like alphabet, I think they're being replaced by nothing. And then everything is set to lowercase. And then we are just replacing punctuations with spaces.
What
Have,
does this, what is the name of this process?
the name of the process.
Stemization, no?
Ah, yes, yes, it is. And then I think we are splitting the line into words, and that's the loop that we have at the bottom, I think.
Okay, yes. So this part has nothing to do, well, yes, it has to do with, it's a preparation phase. Do you know what NLTK is?
No, I don't.
Okay. NLTK is a Python library that deals with a natural language processing.
Natural language, right? Toolkit.
This is why it's NL, natural language tokenization. You remember that in order, when we have textual input, we have, well, it's a string. So we have to identify the tokens. And then once we identify the tokens, we are going to filter the tokens. And this is a stemization problem. And what we are doing is getting rid of stop words, okay, and also of punctuations. Of course, this cannot be a general process. You have to know which is the language of the text, because depending on the language, stop words will change. Remember that stop words are adjectives, are pronouns, are well, all the are they called, pronouns, and then when you say 1, 2, 3, what's that? That's numerical adjectives. Okay, so all the grammatical elements that help us build sentences, but in fact that come up too often and do not have an impact on the content of the words. So these are stop words. And we have a very evolved thing, because Python already provides files with stop words in many different languages, and here we are using English. Okay, so it has for German, for French, for Spanish, etc. So we are using this library in order to have a look at stop words and then punctuations. You see that here there is the hypothesis of the type of punctuations that we are expecting in the document. So if there are other punctuations, then it will not filter them. Okay. And of course, we have to specify the encoding because we are dealing with strings, and you know that strings have different representations. And so we have to specify which is the representation that was adopted in the documents in order to deal with these strings. Okay, and then, well, the tokenization and the stemization process will lead to words that are representative, and here we have the famous data structure that we have been observing in the course, and that gives represents the identification of a term, of a word. So well, here we have much more complex operations that in the example I have presented, because here the map function includes all these data preparation part that we didn't see in the examples that I presented, just to get you acquainted with the idea of the MapReduce model. Okay. And then the reducer function. What does the reducer function do? Well,
I think it takes all like the produced outputs from each of the uses of the map, like each of the different like outputs from the map, and then like reduces them into a single like.
You see, here it is.
Yeah, like
and then and then what does it do?
I think like it's from each line it gets the count like for each word, and it's repeat like the amount of times it gets.
What is the data structure that it receives?
I think it's a tuple.
It's word and count. It's tuples containing a word and, well, two elements.
Yes.
You see, here are the two elements. Then it's not confident about that it receives really an integer here. So what it does first is it casts this value, this count, in order to make sure that, well, it transforms it into an integer, and if it's not possible, then it will ignore that. Okay, so there will not be no error, but it will ignore that. Okay, and this is very important because having errors in parallel processing is very bad news because it's difficult to debug. Okay, so you never know either if the result comes from your program logic or whether it comes from the fact that, for example, there was a connection error and the process, in fact, went fine, but it didn't produce a result because of some connection problems or because the server went down, and so etc. Okay, so this is why it's difficult to debug, and you have many processes. So the error comes from which process? Never know. Okay, so in order to avoid this little code, in fact, discards possible tuples with non-integer values in the second element. Okay, and then what happens? Come on, guys, otherwise it's very boring. We're going to die here.
I think that what it does, it starts like it checks if the last word. I'm not completely sure about this part, but I think what it does is that it takes each word and then starts adding all of its occurrences. So that's why you have a current word, so it's a word that just used, and it also has a current count, which is the count of that word. And then
In fact, what happens is that the result can contain duplicates. Okay, so it's just the very the simplest version of count words, where you can have two times sleep one. Okay, so it assumes that Hadoop has organized the results of mappers, and that all the tuples that have the same key have been grouped together. Okay, so it's going to go through the list and look for duplicates. If so, it goes for the first line if such a key has already been observed, then it doesn't create a new tuple, but it summates the occurrence of this, okay, this new occurrence. And if the tuple has not been, the key has not been seen before, so it creates a new tuple with the key and the current value, which is 1. Okay, and then it comes again, and imagine that it a new tuple with an already visited key comes up. Then instead of creating a new tuple, it will only summate the occurrence, and this is this. Okay, so if the current word already exists, then just summate the count. If it doesn't exist, then it creates a new tuple with the new key and the current value, which is 1, because it initiated this with 1. And so on and so forth until it exhausts the list. Right.
Dr. Bro, I have a question.
Yes.
Are the words in order? Alphabetically sorted?
Yes, I mean that's the task done by the shuffle and sort. It groups by key, and so if it groups by key and the key is a string, then all the strings starting with the same. It's not ordered. Well, it's ordered also. Okay, but the shuffle, it will do, it will group together all the tuples that share the same key. So you have groups of duplicated terms, okay? Many tuples with the same key. And then, of course, it also orders because that's easier. And since the key is a string, then it orders it in a lexicographical order. But this is done on the sort and shuffling part, which doesn't belong. So this is why here it assumes, well, here you have here you have the comment saying that because Hadoop sorts output by key, then you can assume that all the tuples with the same key have been grouped together, and that you will get them in the reducer, in each reducer.
Dr.
Right? Did I answer?
Yes. Wouldn't it be easier something like this? Let me show you.
Let me stop sharing.
No, I'm just putting it on the chat.
Okay. No, I mean dictionary. You cannot have dictionaries because the only structure that you can have is key value. No dictionaries here. As long as, well, maybe the value can be a dictionary since we are in Python, but it doesn't understand dictionary as input. It's key value.
Oh, okay. Yeah, well, what I was thinking is maybe like using the dictionary as an intermediary step, and then finally. I think that.
And why do you want to implement this if the Hadoop infrastructure does it for you? You don't have to implement it.
Okay. Okay.
It's like as if you were telling me, why don't you implement concurrency control on the application, but why would you? The DBMS already does it for you.
Oh, okay.
Right. It's restrictive in the way we have to force us to reason only about key values and how do we split the operations. But once we are comfortable with that, then sorting, shuffling, etc., is done by the infrastructure. In an advanced setting, according to your data, you might change the algorithm used for sorting or for shuffling. But this would be a tuning the architecture, and this is for very advanced use of Hadoop. Otherwise, you can live with this without any problems. And going back to your data structure, the more complex you have your data structures, the highest overhead you have. So here you have to make it as simple as possible so that things run. I mean, you're not optimizing code. You're just expressing as simple as possible the map and the reduce function. This is the principle of the programming exercise in this process, because other difficult things you will address, I mean, in the code. So no need to complexify the process. But anyway, is this clear?
Yes, doctor.
Yes. Okay. So, well, those are map and reduce, and then of course we execute. Well, now I'm going to explain in a minute well, here of course we have Python, so we have the mapper and the reducer Python functions. We have to give rights to the operating system in order that it can use the files and run them on Hadoop. And then, well, there are many, in order to run here, we have more specifications about this. We have, of course, to say the address of the input. We have to say where do we want it to put the output. we have to specify the names of the mapper and the reducer. They must be called mapper and reducer, okay? And then we have to say that these two files are Python files. Sorry, Python files. Okay, and well, all this lets the engine prepare the environment in order to execute. And one extraordinary thing is that, well, we are using the same Hadoop engine, and as I said last time, it understands different programming languages. So we have to make the effort of designing the map and the reduce and the data structures, but in general, we can program using the programming language that for which we are more comfortable with. And then it happens, well, it does the same. And here what we did is we showed the problem with this is that the input file is, okay. So it executes and as I said, we only know that it was executed with success and that the result lies in this folder that we specified. Okay, and the result always, file is always called like that unless we modify it. And you see here we have the result. So have a look that our terms can be very different. These are hexadecimal terms where we have only one occurrence for many of them. And then for some of them, for example, we have more occurrences within the input file. Okay, and so on and so forth. Well, I mean, that's what was expected, which is counting every term. And one important thing that you should see is that, for example, the hexadecimal terms, we could have developed a more interesting cleaning strategy in order, for example, to get rid of these terms that might not be very interesting. Maybe these ones yes, but the hexadecimal, let's say this one, which is hexadecimal, I believe, might not be very interesting to know how many occurrences there are. But if you consider that you are, for example, in a setting where you are operating in order to clean your data, a first thing that you would do is you go and see what are the terms and which of them you can impute and get rid of them in a second version of your program. So your program would be looking for stop words, etc., and all terms of X type, for example, integers, etc., in order to really keep the terms in English, for example. That would be a way of modifying the cleaning part in a more in a fancier manner. And this would be I mean, if you have implemented a search engine, this would be the first process that should be done for processing documents and building the frequency matrix, for example, and then eventually the inverted index, that are the seeds for a search engine. Have you implemented a search engine?
Yes, well, we did kind of that in our, I think it was in our advanced databases course with Dr. Sekinali. We implemented, like, we did like a similar project like this with systemization, and well, we were using I think a library called Snowball.
Yeah. Well, of course, there are already existing libraries, but these libraries are not implemented in parallel. So an evolution of what you implemented in information retrieval would be to do these processes under a MapReduce model and then run them in parallel. And now you have your little Google solution. Okay, questions until here? It's done, yes, by the Hadoop engine. And the other part I didn't get. Wait a minute, how do I do? I'm going to use this second screen. And when that it happens? Well, I'm going to share my screen, my PowerPoint, and let me, yeah. You have, well, I'm going to duplicate this to show you what we have. What we have in this implementation. Okay, so in this implementation, what we have is like this. Well, I'm going to copy this. Right. So in the implementation we have seen, this is the mapper. Okay, so it receives a text, and for every term it gives a 1. And this is the tuples key, this is the key, and this is the value. And it produces this. And then the shuffle part would be to put all the tuples with the same key together. So we have C, we have throw, and that's it. No? That would be the shuffling part. Okay. And then the sorting part, once it has this, it would order, it would sort. So it would do this, and then this, and this. So it executes the map function, and the map function, well, in fact, map would be here, no? Oh, shit. Map would be here, and this is the result, no? So I have a text as input, I apply map, and it produces this list of tuples. Then the shuffling part will group together the result of the map according to those that share the same key. So we would have a first group with the key C, a second group with the key Bob, throw, spot, and run, and then the sorting part would order them in a lexicographical order because the key is a string. And once this is done, so this is Hadoop engine that does this. Yeah. And so this is the input for reduce, and then reduce processes this and produces, so it processes it, and then it goes with the first, and so it produces this. Then there are no other bobs, so it has finished with this. Then it goes for C, and then it will have C1, and then in the second iteration, it will have a look to that C has already been processed, so it will summate the current with the new one, so it would be 2, and then spot, etc. And it's good to reduce. So this is what we implemented, and this is Hadoop engine.
Okay. So, Doctor, then in that case, the map component receives the XML files, and then
Or the string files or whatever, yes.
Yeah, well, the text, and then it gives to the shuffle sort the tuples, right? And then the shuffle sort.
It gives to, in fact, it gives that to the file system.
Okay, the file system.
So this is stored in the file system, and then the engine sees that mappers have finished their jobs, and so it goes and retrieves the data from the file system, so the results produced by the different mappers, and it does this work. And it stores particularly this, again in the file system. And then the job tracker says, okay, so shuffling and sorting part have finished. Now I'm going to start the reducer processes, and they will be fed by this input. So they pick from HDFS, and they use pieces of this data to run.
Okay, so then there's no direct interaction between the map, the shuffle, and the reduce. So no. They directly interact via the
HDFS, yes. Yes.
Okay.
And this is in fact the principle of parallel programming in general. Processes interact through memory or through a space, a common space.
Okay, and then after the reducer is done, does it gives back the data to the
file system?
Okay.
You see, this is why here in the here we are cutting the this file.
Yes, you're right.
Yes.
Okay. Thank you, Doctor.
You're welcome. So this is nice. No, it's interesting. Of course, this is very low level, okay? If we are building an application, there will be other layers on top of this, and then we would have a web application or a software as a service application, whatever you need. This is really the back end of the back end. Other questions before we go on? Yes, please.
Yes, teacher. So now comparing the first example with the second example. In the first example, we also used map and reduce functions.
Yes.
Okay.
But we didn't cut them, I think. I was lazy. No, I was not lazy. In fact, I will show you today. We are supposed to, to do a grep. So this is why I didn't do that. But I'm trying to see whether in the log we have something like that. Yes. Well, here this is Java. Okay. So when you use Java, you implement your map and your reduce functions. And here there are other examples, but suppose that grep is the only one, and you have to create a jar. And then once you have the jar, then you call the one that you want to execute that contains the map and the reduce. Okay, this is why I don't like Java to explain, because given the fact that you put everything together in a jar, you do not longer see the map and the reduce, but you have a mapper and a reducer too.
Okay, and it's in the jar file?
Yes.
Oh, okay.
In fact, the process would be you implement your classes, you create a jar, and then you give it to Hadoop. Well, here, as I said, there are other examples. No, they jarred everything together. Okay, they were lazy, but here, so it contains. There is a kind of main. We will see today that there is a main, no, and the main is calls. I mean, grep calls the main of both elements that are contained here. And then you provide the input and you say where do you want the output. And here particularly it has an input parameter, and your input parameter is the expression that you want to look for. I mean, it's the grep regular expression that you give as input.
Okay.
But the thing, you see, but the thing changes only because, well, for every programming language, we have to respect the way it works. For example, in this one, we even have to configure the Java path, the Java home, no? Whereas in Python, no, because it's more flexible.
So in this case, the map and reduce is in Java, right? In Java?
Yes.
Okay.
Yes. Remember that we did this preparation somewhere here. You see? So we installed, etc., and then we configured the Java home to make sure that then we could use the examples written in Java in order to test the engine.
Okay, I see. Thank you, teacher.
Right.
Yep.
And then we do not longer install because it is installed, and so then the only thing that we do we did in exercise 2 was rely on the installed Hadoop version, but now we implement it in Python. Then there is an important question, which is who does all this? Okay, so who prepares the files and etc. Okay, so I'm not asking you to program because because I want you to understand the programming model rather than testing your programming skills. Okay, so that's first thing. The other thing is that since we are working, by distance, if you have problems, it will be very difficult for me to help you. Okay, so this is why I'm avoiding letting you program directly, and I am using predefined examples that you see and that you can observe the code, etc. Okay, this is because of pedagogical reasons. Okay, so if we were in presence, a nice thing that we could do is, okay, we see some examples and then you start modifying strategies, for example, in order to deal with the stop words, etc. Or I would ask you to, for example, implement the inverted index or things like that. But I'm avoiding problems. This is why. Okay, I'm not very brave person, and so I'm doing this. But anyway, in order to configure, well, there is a lot of configuration and a lot of preparation of environments that someone has to do in order to comfortably tune a Hadoop engine and then run it on standalone, as we are doing, and eventually running it on some cloud provider. Okay, so there are companies and groups, open source groups, that already provide a lot of help and a lot of guidance in order to help programmers care about their problems rather than caring about these environment issues, okay? And one that I chose to use for the course is MR Job. I always call it Mr. Job, but it's MR Job. I'm going to put the link here. So MR Job is available, it's on GitHub, okay? And so what it does is it provides, particularly for Python, a lot of programs and predefined exercises in order to run Python programs on Hadoop. And a particular thing that it does is that it provides also predefined solutions for running Hadoop processes, well, for running processes on top of Hadoop engines that lie on Amazon, or also there is also for Microsoft, so that you do not care about that. Okay, so they make this transparent, and so, well, if you go and have a look at their GitHub, they provide the examples, and then they have a vademecum for running things on standalone, on HD site, which is the Azure solution, or Elastic for Amazon, okay? And so in that way, programmers do not have to figure out how to do these kind of things. So I'm telling you this because this is what we will be using next, and also because this is an example of, well, they are free, okay, but this is an example of the kind of startup that you can found if you have this entrepreneurship spirit. Okay, so many communities and programmers, etc., lose a lot of time in these environments preparation, etc. So there are companies and groups that provide you this, and this is quite appreciated, and there is a market for that. Okay, so this is an example of what you can do if you like this and you want to do this professionally. Okay, so this is so I have shared the description of MR Job, and this is, I mean, I have done this for you, but you can have this view of the of how to configure, etc. Okay, so that's something that we will do. I just want to make clear that in this part of the course we are focusing on algorithmic and more or less programming issues. In the next part of the course, we will do DevOps, And in DevOps, we will more or less come back here in order to learn how to design composers or whatever virtual machines, etc. So how to prepare the execution environments, how to install them on the cloud, and then use them in order to run solutions. Okay, but for the time being, I'm just being general because we haven't addressed neither virtualization nor componentization, and so we will see this in order that you have a complete fundamental knowledge of how these things work. Okay, so do not think that we are going to, it's simple, but we are going to touch every little element of how things work, how you prepare and work with these, so that eventually you can go further and zoom into some matters, but that you have the general vision of how it works, and particularly how it works on the cloud. Okay, so that's MRJob, and this is the library that I'm going to rely on for the next exercises. So yes, please. While I look for something, please.
Oh, sorry, doctor. I just wanted to confirm a very simple doubt. Is the it would be that then Mr. I mean not Mr. MR yes, MRJob is just what allows Hadoop to communicate or understand, interpret Python code.
In fact, MRJob, what it provides is, first of all, a lot of pre-programmed examples of MapReduce problems. That's one thing. And then the other thing is it provides you instructions in order to deploy these programs either in local, and standalone, or on the cloud. On different cloud providers, because if we say the cloud, then it's nothing, okay? In different cloud providers. That's it.
Oh, okay. Well, excuse me. When you say programs, do you mean like Python programs with Hadoop?
With Python.
Ah, okay.
Remember that Hadoop is just the execution environment. The map and the reduce functions we can program on Python, on C, on Scala, on different languages. I'm using Python because it's intuitive. And MRJob provides examples with Python.
Okay, very well. Thank you, doctor.
You're welcome. So I'm just going to give you them. The link, well, this is the GitHub link of, so that you see. Nice that you asked. So if you go to the GitHub of MRJob, I'm going to share it again here. Any information, I know, sorry. It's a mess, but it's not my mess, it's the discipline's mess. Okay, so this is the GitHub of Mr. Job. So you have here, well, examples, documents, a lot of tests. And then here, if you, well, they tell you how to install, but this is not, you see here, they provide you help on how to set up EMR, which is the environment provided by Amazon in order to execute on Hadoop engine. They also provide you with instructions for Dataproc in Google. And then at some point, well, in this version, at some point there was one page that they have, and they show you how to use HDSite, which is Azure. Why aren't we using this? Because all of these do not belong to the free trial, neither to the student program trials. Okay, so for that we need a credit card. So what I will do is I will explain, etc. And then once we will know how to do DevOps, we will use our own cluster implementations in order to run our Hadoop environments in these virtual implementations. But this is because we do not have a credit card that pays this. Okay, it's just that, but it's not bad because you will learn how to prepare your virtual machines, etc. So we will win anyway. Okay, so that was, and then I'm going to share this, which is mine. Right, so do not hesitate to answer, to ask, because there are many things. So we are going back and forth, and I believe that if suddenly you looked away and you come back, now we're talking about another very different thing. Okay, so do not hesitate to ask. So please go to the link that I provided, and then you can open that in Colab so that we have a look on this. And we show how we. So I want to minimize this to make sure that I have the less number of windows as possible. Please tell me when you have opened the notebook. Again, of course, I'm using notebooks again for pedagogical reasons. You can, of course, implement a normal environment, and then okay. So I'm gonna even close this. So this is example 3 because we did 2 examples before. Okay. And well, first of all, this I will explain in a very briefly manner because it's the version of counting words but using Python. Okay, and then I will profit to show you how do these functions look like. So what the first lines, what we are doing is we are installing all MRJob code because we are going to use these predefined programs in order to study them. Okay, so we install MapReduce job, and then well, we copy the examples in this folder. So this is a first example. Again, that I'm going to use to show you how the programs look like in Python using these predefined programs, and those that are eventually lost will hopefully find themselves within this Hadoop MapReduce universe. So the objective of the program that we are going to have a look at is count frequent words containing the letter U. Okay. I remember that in the regular course, we started having a look at patterns. This is a combination, well, yes, it's a combination of 2 patterns, counting, the counting sub-pattern, and filtering. Okay, so we are addressing the first 2 MapReduce patterns that are introduced in the regular course. So just to have a look on how do we use the environment, we will see the code in a moment. So, well, in Python, what we say is we do an external call to the operating system, saying that we are going to execute in Python these programs. Well, this program, which is called MR words counting using and you frequently count. When we in MR job, when we give this command, I mean this parameter, we are saying that the execution must be done in the standalone version. Okay, so eventually, if you have a look at Mr. Python GitHub, this will change if we are executing on top of Elastic in Amazon or on Google, okay, or in HDSite in Azure, okay. But anyway, so this tells the engine where to execute, where does the processes generated by the Hadoop engine will run. Okay, so in this case, they're running in a standalone context. And then here we are giving the path to the input of the program. And so once it runs here, well, here is they have done a friendlier version because they cut automatically the results and they put them on the log. Okay, so we will see in a minute what does it contain. But they say that the words containing you in the string are through and are son, and that they appear once for through and twice for son. Okay, so it's only words containing the letter U, and then we count the frequency. So how does it look like? It looks like this. We have a class called MR count lines by file, and this class will contain the mapper and the reducer functions. Okay, so it's a very simple version of both of them. What it says is that it receives this key value input. And note here that the key can be anonymous. Okay, we're going to count line by line. Okay, we're going through the lines of the input record, and instead of defining an official key, we say that the key is this, anything. Okay, and then we associate it to a line. And so the result will be tuples for every line with number 1. Okay, so we are processing, instead of processing word by word, we are processing path line by line. Okay. And then the reducer does what we are used to have. So it's the path of the input and then the one. Okay, this. And then you have a kind of main that runs the map and the reducer. Of course, these are directives to the engine that it will interpret as generating processes running the mapper, then retrieving partial results, and then triggering the execution of the reducer, and then providing the final result. But for us programmers, we do not care about this. We just define our mapper and our reducer, and it will be the engine that will be able to interpret this as this parallel execution of these two functions. Yes.
Excuse me, doctor. I was seeing the code and I just wondered, where is the run method defined in the, or is that the method already from the MR job class?
Where is the?
Yes, the run method. Like I was thinking, where is it defined? Or is it defined in the MR job class?
It's in the MR count line. Well, in your, you create a Python file. You have your two functions, and then you have this, which says that you run it.
Yeah, it was just, but doesn't that function need to be defined? As in,
I know it's a proper. It's interpreted by Hadoop. You don't have to implement this.
okay, all right. Thank you, doctor.
Mm-hmm. It's nicer that you can imagine. You just really implement mapper and reducer. The rest you delegate to the engine. I mean, an advanced course would be how to program a Hadoop engine. And there we can have fun.
Okay.
It's the
Okay, it's
same
very
as the
simple then.
DBMS. No? How do we program a DBMS? Great thing to do.
No, that's
Right.
kind of tough.
Mm-hmm. But it will be great, you know, imagine. I would like to program that. What was I saying? It's this, yes. Well, I let you execute. So what you have is this. You have, well, you have different files, and it tells you then the number of items per line. Okay, so this file contains 8 lines. This file contains 16 lines. This file contains 31, etc. What it's nice is really the same principle of count words, specialized into different operations. And well, since you know how to program and you know many different examples, you can see that these are the seeds in order to, as I said, to program search engines, to clean text, to, for example, this would be interesting if you want to estimate, for example, the size of memory that you need in order to deal with these files, okay? Or the allocated space within disk that you have to assign if you are the file system, for example. Again, of course, I'm not talking about fancy final user applications. These are applications in order to build environments, okay? Building a file system, estimating memory space, arranging or allocating storage space for a given set of files, these kind of things, okay? And we go back to grep. Questions until here? Yes, I have a question. The previous exercise that we did for, the last week's session, you were supposed to provide a document with some analysis, UMLs, etc. Did you manage to hand in this? Well, are you aware that you have to do that? In fact, it was due today.
For what we saw at the beginning of the class?
Yes, it was the first exercise, and then what I was asking for was, let's see what I asked for. Yes, I was asking for a UML component diagram for the Hadoop environment, for the map reduce count words, how the first example implemented grep. Well, these 5 elements that have to include the report. Did you manage to hand in this? Yes, no, maybe. Yes, I can. Of course, I can. Well, I figured out that if I'm asking questions that you on the type of questions you are asking, I think that you really need more time to analyze this thoroughly. Just make sure that every time I give you more time, which I have nothing against for, but at the end of the semester, you have to figure out how to finish the things that we have to do in order to finish the program. Okay, so try to keep the pace, because otherwise at the end of the semester you will become crazy and you have to prepare, I imagine, other exams. Yes, Carlos.
Yes, doctor. Actually, I think that what happened was that since we had to hand today both the map reduce exercise and the second round of the polyglot evaluation, we got a bit saturated because
Yeah. Yes, but I asked whether whether 20 seconds was good for the second round, and you said yes. Well, I suppose that you were aware that you have to manage 2 exercises. Right. So again, I have nothing against giving more time. For me, as I have insisted, the most important thing is that you understand, not that you do exercises for doing exercises, but you have also to organize your agenda. Otherwise, at some point, you will have everything together. Right? So that's the only thing. Yes, of course, I can give more time. Why not? Okay, so I will extend the deadline, but again, try to keep the pace. I know that there is a lot to do, but this is a problem of final courses of your education that, well, they become a little bit more verbose. It's not more difficult, but it's more verbose. Okay. In the 2 minutes that we have we remain, what I will do is, because the second evaluation of the lab has to integrate, as we have been doing, several exercises. So I need you to do another exercise in order having a look at the functions that are contained in this notebook. What we are going to do is the following. Well, you will hand in at some point the first Hadoop exercise. And then next time, what you're going to do is you're going to analyze thoroughly the remaining functions provided in this notebook. And we are going to play. You as a class are going to challenge me, okay? So we will do a contest. You will start with X, I like games. You will start with X number of points. I will ask questions, and if you do not answer, the points will be reduced. But the challenge is that at the end of the session, the whole class will have gained or lost a specific number of points. Okay, so if the class wins all the points, then all the class will have achieved for the second Hadoop exercise, let's say 15 points, okay, or less. That's what we will do, so that you do not have to hand in, but you have to study the code. Is this fine? Is this clear?
Could you repeat it one more time, teacher, just to clarify
All
it?
the class will challenge me to gain some points, to gain a grade. Okay, and I think that we will, let's say that you will challenge 15 points. So you prepare this, you study this, you understand, etc. And then next class, I will provide questions, and then you will win or lose points as a class. So all the class will win the same or lose the same number of points.
Sounds interesting. I like it.
Okay. Yes, Alexander.
Thank you, Doctor. I just want to ask, the questions that will be seen in class or will be competed will be about. That's the part that didn't. I'm sorry.
About the different, you see in this notebook there are several exercises. We went only through the first one. There are, I think, let's see how many of them we have. I think that we have, it's not a lot, we have like 3 more or 4 more exercises. So you have to analyze the code as we did today. You analyze the code, you know what the code is doing. You will see that at the end you have combiners and reducers, etc., implementing the different programs. So you will go, you execute them, you analyze them, you understand what is going on with all these, and that's what you prepare for next Tuesday. And then we play.
Okay, sounds cool. Thank you very much, Doctor.
You're welcome. Other questions? Questions? Answers?
Doctor, which is the deadline that we're going to extend?
For the first one, I think that next Saturday or next Sunday can be fine. Is it fine? Is it?
But for which work?
For the only one that you have to hand in, which is this one. The other one, well, you have to prepare, and if the question comes to you and that you lost points, then your other colleagues will punch you at the end of the session, but I cannot defend you.
Oh no,
I'm
is
too far away.
no, that's very clear for me. No, is that I had the doubt if we were going to extend the polyglot, but I don't know.
No, the polyglot. No. The polyglot, we need to, because I need to have a first term grade. All my colleagues have grades, and me, I have points. No, the polyglot is already there. The only one that I'm changing is this one. Right? More questions? Okay. So if you don't have more questions, we can close the session. I can free yourself so that you can finish the second round, and I'll see you on Friday. See you. Bye.
Thank you, Doctor. See you on Friday. Have a nice day.
You're welcome. Have a nice week.
You too. Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye.